Take a deep breath in, letting the cool air fill your lungs, and as you exhale, allow your body to settle completely into the heavy comfort of your bed. Tonight, we are leaving the grounding pull of Earth's gravity behind to become the fastest, most elusive entity in the known cosmos. To ride a photon across the universe is to experience reality without the burden of weight, because a photon is a fundamental particle of light that possesses exactly zero rest mass. This absolute lack of physical mass is the secret to its freedom, allowing it to travel at the ultimate speed limit of the universe. In the perfect vacuum of space, a photon moves at exactly 299,792,458 meters per second. At this speed, the heavy, dragging sensations of the physical world simply fade away, replaced by an infinitely smooth, frictionless glide. Imagine yourself as this pure packet of energy, a singular quantum of the electromagnetic field. You are experiencing a physical phenomenon that British polymath Thomas Young first proved in the year 1801 with his famous double-slit experiment, the miraculous wave-particle duality. As you move through the dark velvet of space, you behave as both a rippling wave and a solid point of energy. You flow like a gentle swell on a calm ocean, yet you carry a distinct, indivisible pulse of power. It is a state of perfect balance, vibrating with quiet purpose. Let us trace your journey back to the moment of your birth. You are created deep inside the unimaginably dense core of a star, much like our own sun. The temperature here is a staggering 15 million degrees Celsius. In this profound, crushing heat, atoms cannot hold their shape. Hydrogen nuclei are stripped of their protective electrons, creating a thick, swirling sea of charged plasma. Under immense gravitational pressure, these raw protons are forced together in a delicate sequence known as the proton-proton chain reaction. When these hydrogen atoms successfully fuse together to create a heavier element called helium, a tiny fraction of their original mass is lost. According to the foundational laws of physics, this missing mass is converted entirely into pure energy. That radiant, newly born energy is you. But you do not simply fly out into the empty void of space immediately. Your journey begins with a profound lesson in patience. You find yourself trapped inside the star's radiative zone, a spherical shell surrounding the core. The plasma here is so densely packed that its density is roughly 20 times that of solid gold. You attempt to fly outward at your incredible speed, but you almost immediately crash into an electron. When you strike this electron, you are absorbed. For a fraction of a millisecond, you cease to exist, your energy elevating the electron to a higher, vibrating state. But the atom quickly seeks its resting state, and as the electron settles back down, it re-emits you, casting you out in a completely new, random direction. You fly a fraction of a millimeter, only to be absorbed and reborn again. This beautiful slow dance is known in astrophysics as the random walk. You bounce left, right, backward, and forward in a microscopic pinball game of staggering proportions. Because of this dense cosmic maze, it takes a single photon anywhere from 10,000 to 170,000 years just to migrate from the core of the sun to its outer edge. Feel the comforting rhythm of this process. It is a slow, methodical percolation, a deep tissue massage of atomic interactions where time stretches out and rushing is impossible. You are nurtured inside the star for tens of thousands of years, bouncing softly, lulled by the steady, low hum of nuclear fusion. Finally, after millennia of this gentle, zigzagging ascent, the heavy pressure begins to lift. You reach the photosphere, the visible outer surface of the Sun. Here, the temperature drops dramatically to a much cooler, glowing 5,500 degrees Celsius. The dense plasma thins out into the near emptiness of space. The path clears. In a fraction of a second, you leap from the surface, free at last, you accelerating instantly to your maximum speed. The journey from the Sun to the Earth spans 1 astronomical unit, a vast silent gulf of 93 million miles, or about 150 million kilometers. Yet, moving at nearly 300,000 kilometers every second, this incredible distance takes you a mere 8 minutes and 20 seconds to cross. But here is something truly remarkable about riding a photon. According to Albert Einstein's theory of special relativity, time is not a fixed, universal ticking clock. Time is flexible, and it slows down as you approach the speed of light. Because you, the photon, are traveling exactly at the speed of light, the passage of time for you stops completely. From your perspective, there is no journey. The 8 minutes and 20 seconds it takes to reach Earth is an experience that belongs only to the people waiting below. For you, Yuri, the trip passes in exactly 0 seconds. The moment of your creation at the surface of the Sun and the moment you gently touch the leaf of a tree on Earth happen simultaneously. You exist in a state of the eternal now, untouched by the aging of the universe, perfectly preserved in a bubble of absolute stillness. As you sail out into the comforting void of the solar system, you encounter the true emptiness of the interstellar medium. Space is not completely devoid of matter, but it is deeply sparse. In the regions between stars, there is on average only 1 atom per cubic centimeter. You glide through these massive, quiet spaces without striking a single obstacle, slipping through the darkness like a silent thought. Though you are invisible in the vacuum, you vibrate with a very specific rhythmic energy. Say, the length of your wave determines your entire identity. If your wavelength falls between 380 and 700 nanometers, human eyes, should you meet them, will perceive you as visible light. If you stretch out into a gentle, long wavelength, near 700 nanometers, you carry less energy and will be seen as a deep, warm, soothing red. If your wave is shorter and more energetic, near 380 nanometers, you will glow as a soft, calming violet. This relationship between your energy and your frequency is perfectly mathematically bound by a microscopic value known as Planck's constant. This number is so deeply embedded in the fabric of the universe, so astonishingly small, it is written as 6.626 times 10 to the negative 34th power joule seconds. It is the microscopic heartbeat of quantum mechanics, a gentle pulse that ensures your color, your heat, cha, and your power are perfectly balanced. And though you possess exactly 0 mass, your movement carries a ghostly, undeniable force. Photons carry momentum. When you strike a physical surface, you exert a tiny, almost imperceptible pressure, known to physicists as radiation pressure. This gentle push is real, and it is a force that human engineers have learned to harness. In the year 2010, the Japanese Space Agency launched Icaros, an experimental interplanetary spacecraft. Icaros was propelled entirely by a solar sail, a vast sheet of polyimide resin, measuring 14 meters across, yet only 7.5 micrometers thick, thinner than a human hair. By catching the gentle, continuous push of countless photons just like you, the spacecraft sailed silently all the way to Venus, riding the softest breeze ever recorded. Perhaps, though, as we drift through this visualization, you are not a photon born in our local sun. Perhaps you are a much older traveler, a quiet nomad from the very dawn of time. The oldest photons in the universe belong to what we call the cosmic microwave background. If you are one of these ancient waves of light, you have been drifting steadily through the dark void for exactly 13.8 billion years. You were born in a time of incredible density and heat, but you were held captive, unable to move through the thick, opaque fog of the early cosmos. You waited until the universe entered the era of recombination. This was the magical moment when the rapidly expanding universe finally cooled to a temperature of about 3000 Kelvin. At this precise temperature, the chaotic fog lifted. Electrons bound themselves to atomic nuclei for the very first time, creating the first stable atoms of hydrogen and helium. Space became transparent, and a brilliant flash of light was released in every direction, all at once. You are a surviving piece of that very first light. You have been traveling endlessly ever since, witnessing the slow, majestic rotation of galaxies forming from clouds of dust. Over those 13.8 billion years, the universe has not just been sitting still, it has been expanding, stretching the very fabric of space outward. And as space itself stretches, so too does your wavelength. This beautiful, slow relaxation is known as cosmological redshift. What began as blazing, energetic white heat has been stretched and calmed, elongated into faint, invisible microwaves. The intense energy of your birth has been soothed by the immense age of the universe, cooling down over billions of years. Today, the ambient temperature of these ancient photons is a deeply frigid, perfectly steady 2.7 Kelvin, just a fraction of a degree above absolute zero. It is a profound cosmic chill, representing the ultimate peace of the universe. You are surrounded by a soft, static glow that fills every inch of the night sky, unseen by human eyes, but felt by the great radio telescopes of Earth. You are the echo of creation, drifting forever in a quiet, undisturbed line, completely at rest while moving at the ultimate speed, embraced by the comforting, endless void. As you continue this boundless flight outward, untethered from the heavy pull of planetary bodies, it is deeply calming to reflect on how long it took humanity to understand the very nature of your journey. For centuries, our ancestors looked up at the night sky and assumed this delivery of starlight was instantaneous, a magical connection between the heavens and the eye. Picture the quiet observational nights of the year 1676. A Danish astronomer named Ole Rømer became the first human to realize that light actually takes time to travel. By carefully tracking the orbit of Io, the innermost, violently volcanic moon of Jupiter, he noticed a rhythmic discrepancy in its celestial clockwork. When Earth was on the far side of its orbit, millions of miles further away from Jupiter, the eclipses of Io appeared exactly 22 minutes later than when Earth was at its closest approach. This elegant observation proved that you, the photon, are bound by a finite speed. You move like an ancient courier, carrying a sealed letter across the dark, a silent ocean of the solar system. Over time, our understanding of your rhythmic mechanics grew much more precise. In 1849, the French physicist Hippolyte Fizeau brought this cosmic measurement down to the surface of our own world. He constructed a brilliant experiment, shining a bright, focused beam of light through the gaps of a rapidly spinning toothed wheel, reflecting it off a mirror situated exactly 8 kilometers away on the hill of Montmartre in Paris. By calculating the exact rotation rate of the wheel needed to catch the returning flash in the very next gap, Fizeau estimated your speed at roughly 315,000 kilometers per second. This was a breathtakingly accurate calculation for the 19th century, capturing the elusive pulse of the cosmos with mere brass and glass. As a traveling photon, you are only bound to your absolute maximum velocity when gliding through the empty, uninterrupted vacuum of space. When you encounter the physical matter of planets, moons, or atmospheres, the rules gracefully shift. Consider what happens when you dive from the vacuum into a serene pool of water on Earth. As you interact with the dense, vibrating molecules of H2O, your overall progression through the liquid slows down to roughly 225,000 kilometers per second. Should you strike the rigid crystalline carbon lattice of a diamond, this dense optical environment slows your journey even further, bringing you down to a comparatively leisurely 124,000 kilometers per second. The diamond forces you to take a more intricate winding path, bending your trajectory and scattering your colors through a phenomenon known as refraction. In this gentle bending is what creates the brilliant internal fire that humans prize in gemstones. Scientists have even learned to coax you into a state of near-perfect stillness. In the year 1999, a Danish physicist named Lene Howe achieved something that sounds like pure magic, yet is entirely rooted in quantum mechanics. By shining a laser into a cloud of sodium atoms, cooled to just a billionth of a degree above absolute zero, a highly ordered state of matter, known as a Bose-Einstein condensate, she slowed the speed of light down to a mere 17 meters per second. That is roughly the speed of a person riding a bicycle on a quiet afternoon. The light compressed, its waves stacking up like accordion folds in the biting cold, until it practically paused in midair. But let us return your focus to your unhindered flight through the deep cosmos. As you journey, you are not alone. You travel alongside countless other photons of varying lengths and energies, creating an invisible, layered symphony of radiation. In the year 1800, the astronomer William Herschel decided to measure the physical temperature of the different colors found within sunlight. He used a simple glass prism to separate the light into a rainbow, placing mercury thermometers in each colored band on a table. He discovered that the ambient temperature rose steadily as he moved the thermometer from the violet edge down toward the red edge. But his true revelation occurred when he placed a thermometer just past the red band, where absolutely no light was visible to the human eye. The temperature in that empty shadow was the highest of all. Herschel had just uncovered infrared radiation, photons with wavelengths longer than 700 nanometers, carrying invisible warmth through the dark, wrapping objects in unseen heat. The very next year, in 1801, a German chemist named Johann Wilhelm Ritter searched for hidden energy on the exact opposite end of the spectrum. He exposed paper soaked in silver chloride to the dark region just beyond visible violet. The chemical compound darkened rapidly upon exposure, proving the existence of highly energetic, high-frequency photons that we now call ultraviolet light. You exist across this entire unbroken continuum. It is a massive electromagnetic spectrum spanning from radio waves that stretch for kilometers, all the way down to the tight microscopic spikes of gamma rays. What is perhaps most beautiful about your journey is the deeply personal story encoded within your waves. Think of a beam of starlight as a message where the ink is written by the very atoms you pass through before leaving your home star. In 1814, a Bavarian glassmaker and optician named Joseph von Fraunhofer invented a precision device called a spectroscope. When he passed pure sunlight through his flawless lenses, he did not just see a smooth rainbow. Instead, He mapped 574 dark, incredibly thin lines, slicing vertically through the brilliant colors. Think of these dark shadows as quiet silences, resting within a grand chord of light. These are known today as Fraunhofer lines, and they represent missing photons. As light pushes outward from a star's dense, raging core, it must eventually pass through the star's much cooler outer atmosphere. Here, specific atoms act like highly selective toll booths. A calcium atom, for instance, will absorb photons of a very specific exact frequency, plucking them cleanly out of the outward-bound beam. When Fraunhofer looked at the fractured spectrum of our sun, he was literally reading the chemical barcode of its atmosphere. This cosmic fingerprinting is so mathematically exact that it allows us to discover physical elements from tens of millions of miles away. During a total solar eclipse in 1868, astronomers pointed their spectroscopes at the sun's glowing ethereal corona. Amidst the data, they noticed a bright yellow emission line at precisely 587.49 nanometers. This specific wavelength did not match any known substance found on Earth, and they boldly declared it to be a completely new element, naming it helium, derived from Helios, the ancient Greek god of the sun. It would be another 27 long years before helium was physically found on our own planet, hiding quietly in radioactive uranium ore. The light whispered its presence across the void, decades before human hands could gather it. Moving onward, away from the warmth of the stellar nursery, you might find your trajectory intersecting with a vast, beautiful cloud of interstellar dust and gas. Astronomers call this a reflection nebula. The Pleiades open star cluster, located a serene 444 light-years away from Earth in the constellation of Taurus, is wrapped in one of these delicate, wispy veils. The young, massive B-type stars scattered within this cluster burn at blistering surface temperatures approaching 30,000 Kelvin. They radiate an intense bounty of highly energetic blue photons. When you and your fellow blue photons strike the microscopic carbon and silicate dust grains drifting in the nebula, a delicate physical interaction occurs. Because blue light travels in much shorter, tighter waves, measuring around 450 nanometers in length, it strikes the fine dust particles and ricochets, scattering sideways in every conceivable direction. This beautifully chaotic process is called Rayleigh scattering. Meanwhile, the longer, gentler red and yellow waves slip right past the microscopic dust grains, continuing forward completely uninterrupted. The result, painted against the black canvas of space, is a massive, glowing cosmic fog, illuminated in the softest, most luminous shades of azure and sapphire. It is an awe-inspiring celestial watercolor, born from the simple geometry of light meeting dust. Notice how perfectly ordered these systems are. There is no rush, only the steady mathematical certainty of waves and particles interacting over staggering distances. Every photon moving through the dark is a piece of a grand, interconnected puzzle, carrying data from the fiery dawn of stars to the quiet lenses of telescopes resting on distant rocky shores. As you glide further into the deep, surrounded by the indigo glow of scattered light, you are a vital thread woven into the fabric of the night. Continuing onward from that delicate indigo fog of scattered star stuff, we can trace your silent trajectory toward a much more familiar destination. When you, Chang, a traveling photon, finally reach a living observer, the physical interaction is staggeringly precise. To understand the sheer sensitivity of the human body to your arrival, we must look at a fascinating biological threshold. Scientists discovered in the year 1942 through a famous study conducted by researchers Hecht, Schleyer, and Pirenne, just how little light the eye needs to see. They placed human subjects in absolute darkness for 30 minutes to let their vision fully adapt. Through careful testing, they revealed that an average human eye can detect a flash of light when a mere 90 photons enter the cornea. But the comparison becomes even more astonishing when we look deeper into the tissue. Out of those 90 microscopic particles of light, only about 9 actually make it all the way through the fluid of the eye to strike the retina. Picture this incredibly delicate system as the world's most sensitive tripwire. A human retina contains roughly 120 million specialized photoreceptor cells called rods, which are solely dedicated to vision in low-light conditions. When one of those 9 photons strikes a single rod cell, it collides with a specific biological pigment molecule known as rhodopsin. The impact of your tiny massless energy causes the rhodopsin molecule to physically twist and change its shape, a chemical reaction called isomerization that happens in just a few picoseconds, trillionths of a second. This microscopic twist fires a minuscule electrical signal down the optic nerve. It is as if a single falling snowflake landed on a massive, highly tensioned spiderweb, and the entire structure vibrated in response, registering the arrival of a visitor from millions of miles away. Notice how the scale of your energy compares to the everyday objects we handle. A single photon of green visible light carries an incredibly tiny amount of power, mathematically expressed as roughly 2.8 times 10 to the negative 19th joules. To put this microscopic measurement into a relatable perspective, a common house mosquito flying through a bedroom carries approximately 1 trillion times more kinetic energy than you do. Individually, you are gentler than a whisper, entirely imperceptible against the skin. Yet, when photons travel together in their unfathomable multitudes, they become a powerhouse that sustains entire worlds. At this very moment, a constant, steady stream of solar energy is pouring down upon our planet. Astrophysicists measure this collective flow using a metric called the solar constant. At the upper edge of Earth's atmosphere, sunlight delivers exactly 1,361 watts of energy per square meter. Imagine looking at a square patch of sky about the size of a standard dining room table. Within that single square, the incoming photons are delivering the exact same amount of continuous power as 13 standard 100-watt incandescent light bulbs glowing brightly all at once. The sheer volume of these weightless travelers transforms an invisible freezing vacuum into a warm, life-bearing sanctuary. What happens when you descend through the atmosphere and strike the solid objects of a typical human morning? Consider the smooth surface of a standard household mirror. The back of that heavy glass pane is coated with a microscopic, evenly applied layer of silver or aluminum atoms. As you plummet toward this metallic barrier, you do not simply stick to it like a raindrop hitting mud. Instead, the interaction is beautifully mathematical, resembling a perfectly smooth stone skipping across a glassy frozen pond. According to the physical law of reflection, the exact angle at which you strike the mirror, known as the angle of incidence, will precisely match the angle at which you bounce away. If you arrive at a sharp 45-degree slant, you will depart at that exact same 45-degree slant. A high-quality silvered mirror reflects about 95% of the visible light photons that strike it. The remaining 5% are not lost, but rather absorbed by the metal atoms. Those atoms capture the stray photons and vibrate just a little bit faster, converting that specific portion of light into thermal energy, or microscopic heat. Every time a beam of light hits a reflective surface, the glass warms by a fraction of a degree. Deep within the cosmos, however, your path is not always a perfectly straight line, drawn between 2 points. Even though you possess exactly zero mass, you are subject to the grand, sweeping architecture of gravity. Albert Einstein's general theory of relativity, published in 1915, introduced a completely new way to visualize the universe. Rather than thinking of gravity as a magnetic pull between objects, Einstein proposed that space and time form a connected, flexible fabric. Massive objects, like stars and galaxies, weigh down heavily on this fabric, creating deep depressions. Think of a train traveling across a mountain pass. The train does not have a steering wheel. It simply follows the physical curve of the steel tracks laid before it. In the same way, as you, the photon, fly past a massive object like our sun, the very geometry of space curves beneath you. You are still flying straight from your own perspective, but the track of space-time itself is bent. This beautiful phenomenon was famously proven during a total solar eclipse on May 29, 1919. A British astronomer named Arthur Eddington traveled to the remote island of Principe, off the western coast of Africa, to photograph the blackened sun. As the moon blocked the blinding glare, Eddington captured the faint light of stars belonging to the distant Hyades star cluster, which were positioned directly behind the sun from Earth's point of view. Because the mass of our sun had warped the space around it, the light from those distant stars followed the curve, bending precisely 1.75 arc-seconds off their normal trajectory. It was exactly the measurement Einstein had predicted. The heavy physical mass of a star had gently guided the weightless light along a new path, like a river carving a channel through a canyon. When this bending occurs on a much grander, galactic scale, astronomers call it gravitational lensing. Imagine peering through the base of an ordinary curved wine glass. The solid glass dramatically distorts the light passing through it, warping the shapes of the room behind it into stretched, magnified arcs. Entire clusters of galaxies do this exact same thing to the space around them. Take, for instance, Able 2-218, a spectacularly massive cluster of galaxies located about 2.1 billion light-years away from Earth. This cluster contains thousands of individual galaxies bound together by gravity, and its collective mass is so enormous that it acts as a cosmic magnifying glass. When ancient photons from even more distant hidden galaxies travel toward Earth, they must pass through the warped space surrounding Able 2-218. As the light follows these deeply curved tracks, the image of the distant galaxy is stretched, magnified, and multiplied. Sometimes, if the hidden galaxy, the massive cluster, and the observer on Earth are lined up in perfect, mathematical symmetry, the bent light forms a complete unbroken circle. This glowing cosmic halo is called an Einstein ring. It is a stunning visual reminder that the universe is not just empty, static blackness. Space itself has an invisible, flowing texture. It curves, dips, and swoops, guiding your journey like invisible currents in a deep, dark ocean. Throughout this immense, bending journey, you never experience friction. You never feel the drag of wind or the heavy weariness of a long commute. Whether you are navigating the microscopic architecture of a human retina, skipping off the silvered back of a bathroom mirror, or sweeping along the deeply curved valleys of space-time around a galaxy cluster, your movement is pure, unburdened flow. You are the universe communicating with itself, translating the fiery heat of distant stars into the gentle biological spark of human vision, completely weightless, endlessly graceful. Following this graceful trajectory downward from the cosmos, we eventually reach the protective, gaseous envelope of our own world. Observe how the mechanics of light directly shape the physical environment you inhabit every day. As countless photons rain down upon Earth, they are met by a planetary system of reflection and absorption known as the global energy budget. Climatologists measure this balance using a metric called albedo, which rates how reflective a surface is on a scale from 0 to 1. Earth's average global albedo sits comfortably at about 0.30. This mathematical value means that the planet immediately bounces 30% of all incoming solar photons right back into the freezing dark of space. Reflect upon a quiet, freezing morning after a heavy winter storm. Freshly fallen snow possesses a staggering albedo of up to 0.90, reflecting 90% of the light that strikes it. This intense, immediate ricochet of photons is what creates the blinding, crystalline brightness of a snow-covered field, a landscape entirely shaped by the physics of rejected light. Conversely, look toward the deep, rolling surface of the global ocean. Seawater is a magnificent trap for traveling energy, absorbing more than 90% of the visible light that strikes its dark surface. This monumental absorption is precisely what warms the seas, driving the massive evaporation cycles that create the rain, the clouds, and the weather patterns we experience. As photons penetrate the ocean's surface, the water molecules act as highly specific filters. Within the very first 50 meters of depth, the water strongly absorbs all the long, gentle waves of red, orange, and yellow light. With these warmer colors completely stripped away by the water molecules, only the shorter, highly energetic blue photons remain to scatter back to our eyes. This selective physical absorption is the sole reason the deep ocean presents itself in such profound, calming shades of azure and indigo. Think of a single photon as a delicate needle pulled by a cosmic weaver, stitching the ephemeral energy of a star directly into the physical, heavy fabric of life. To understand this profound connection, we only need to look at a quiet, shaded forest. The leaves of plants contain a specialized pigment known as chlorophyll A. This biological molecule has evolved to selectively absorb photons at two very specific, measurable wavelengths, 430 nanometers and 662 nanometers. These numbers correspond to the blue and red bands of the visible spectrum. True, because the pigment heavily absorbs the blue and red energy to power its internal chemistry, it bounces the middle wavelengths away. Those rejected middle wavelengths measure around 550 nanometers, which human eyes perceive as the soothing color green. Deep within the microscopic architecture of a leaf, a truly astonishing event occurs. A plant requires exactly 8 to 10 photons to successfully bind a single molecule of atmospheric carbon dioxide into a stable sugar molecule. This quiet, localized capture of starlight is the foundational engine of almost all life on Earth. Botanists estimate that the global process of photosynthesis produces a staggering 100 billion tons of solid biomass every single year. The majestic redwood trees, the sprawling fields of wheat, chuck, and the blooming flowers in a garden are all constructed from thin air, woven together by the kinetic energy of trapped light. Researchers at the University of California, Berkeley, made a groundbreaking discovery in the year 2007 regarding exactly how this energy moves. They detected a phenomenon known as quantum coherence happening inside the photosynthetic structures of bacteria. When a photon enters the light-harvesting complex of a cell, its energy does not just bounce around randomly like a pinball. Instead, behaving as a quantum wave, The energy simultaneously explores every single possible microscopic route through the cellular structure. By experiencing all paths at once, it instantly finds the most perfectly efficient route to the reaction center, losing almost zero energy in the process. And the plants in your backyard are actively performing advanced quantum computations simply to catch the sun. Notice how this unbroken chain connects you directly to the distant burning core of our star. The carbon atoms that form your muscles, your bones, and your breathing lungs were forged in ancient supernovas, but the energy holding those atoms together in your body right now was delivered by photons. Every piece of food you have ever consumed is, at its most fundamental level, packaged sunlight. Your own physical body interacts with this incoming radiation in deeply therapeutic ways. Consider the biological marvel of human skin. When invisible ultraviolet B photons, those vibrating at tight wavelengths between 280 and 315 nanometers, strike the surface of your skin, they penetrate the outermost layers of the epidermis. Here, they collide with a specific precursor molecule known as 7-dehydrocholesterol. The sheer impact of the UVB photon breaks a precise chemical bond within the molecule's carbon ring. This single microscopic fracture triggers a slow thermal reaction in the human body that takes roughly 48 hours to complete. The end result of this chemical cascade is the synthesis of vitamin D, a vital hormone that allows your body to absorb calcium and maintain the structural integrity of your skeleton. You are functioning as a biological solar panel, using the invisible radiation of the cosmos to build the very bones that support your weight. Furthermore, the rhythm of your daily life, your waking and your resting, is governed by the ancient movement of the Earth relative to the Sun. In the year 1998, biologists discovered a previously unknown photopigment in the human retina called melanopsin. Unlike the rod cells we explored earlier, which help you see shapes in the dark, melanopsin is not used for visual picture building. Instead, it is highly sensitive to a very specific shade of blue light, measuring exactly 480 nanometers. When the morning sun crests the horizon, flooding the sky with these 480 nanometer photons, they strike the melanopsin in your eyes. This impact sends an electrical signal directly into a tiny cluster of thousands of nerve cells in your brain, known as the suprachiasmatic nucleus. This biological master clock instantly sends a message to your pineal gland, instructing it to halt the production of melatonin. As the melatonin fades, you wake up. You are physically tethered to the rotation of the planet. Why? Your awareness rising and falling with the sweeping tide of cosmic light. There is an incredible sense of comfort in realizing how much of human history is intertwined with the delayed release of this ancient energy. Around 300 million years ago, during a geological era known as the Carboniferous period, massive prehistoric forests absorbed uncounted trillions of photons. Over eons, those trees died, fell into swamps, and were subjected to the crushing pressure of the Earth's crust, eventually transforming into dense seams of coal. The fossil fuels that humans have used to power massive industrial grids, light up sprawling cities, and warm our homes are nothing less than buried, fossilized starlight. Even the simple act of sitting around a cracking campfire is an experience of time travel. The wood you place on the glowing embers grew by capturing photons over the last few decades. When the intense heat of the fire breaks the chemical bonds of the cellulose and lignin in the wood, that exact same solar energy is finally released back into the air. The bright dancing yellow flames and the deep radiating warmth on your face are the literal reappearance of sunshine that fell on a quiet forest 20 or 30 years ago. A fire is simply a tree unwinding its trapped light. We find that the universe imposes a beautiful delay on all of our perceptions. Because photons travel at a finite, strictly limited speed, it is physically impossible to observe the universe exactly as it is right now. You are permanently viewing the past. When you look at the moon, you are seeing it as it was 1.3 seconds ago, the time it took the reflected light to cross the void. When you look at the sun, you see an image that is over 8 minutes old. Even when you look down at your own hand, resting on the bed, the light bouncing off your skin takes about a billionth of a second to reach your eyes. You exist in a continuous flowing stream of history. As you rest in the quiet darkness, there is one final, beautifully subtle connection to the physics of light. Human skin emits a deeply faint biological glow. Scientific instruments equipped with highly sensitive photomultiplier tubes have revealed that the human body steadily releases biophotons, emitting roughly 1,000 photons per square centimeter every single second. This ultra-weak photon emission is a natural byproduct of cellular metabolism. It is entirely invisible to the naked human eye, but it is real, measurable physics. You are not just a passive receiver of the universe's energy. You are gently, continuously glowing, contributing your own microscopic starlight to the comforting silence of the room, an active participant in the grand, endless journey of light. Gliding outward from the faint biological glow of the human form, we can begin to explore how the universe translates the silent journey of photons into a rich, sensory tapestry. To truly comprehend the architecture of light, we must ask why it presents itself in such specific, measurable ways. Imagine the cosmos as a magnificent silent pipe organ. In this grand analogy, the chemical elements of the universe are the varying metal and wooden pipes, and you, the flowing photon, are the pressurized air moving through them. Depending on which atomic pipe you travel through, you produce a different perfect note of energy, creating the colors, the temperatures, and even the chemical signatures of the sky. Deep within the constellation of Vulpecula, a profound rhythm echoes through the dark. Scientists discovered in the year 1967, through the meticulous observations of astrophysicist Jocelyn Bell Burnell, an entirely new class of dead stars. She identified the very first pulsar, eventually named PSRB 1919+21. This exotic object is the incredibly dense, spinning core of a collapsed star. As it rotates, its massive magnetic fields funnel photons into two tight, brilliant beams of radio waves firing out from its poles. What is happening now is a cosmic lighthouse effect. Because PSRB 1919+21 spins with staggering mechanical precision, its beam sweeps across Earth exactly once every 1.337 seconds. While space itself is a perfect vacuum, where traditional acoustic sound cannot travel, radio astronomers capture these low-frequency photons and translate their electromagnetic data directly into audio waveforms. When played through speakers, the arrival of these photons sounds like a low, comforting heartbeat, a steady, thrumming thump, 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 echoing from thousands of light years away. It is the soothing percussion of gravity and light, working in perfect, unbroken harmony. Consider the notion of scent within the boundless architecture of space. Because the interstellar medium is a freezing vacuum, a human observer could never take a physical breath of the cosmos. Yet, we know exactly what certain regions of the galaxy smell like, entirely because of the physics of light. At this very moment, massive telescopes are gathering photons from Sagittarius B2, an enormous molecular dust cloud located approximately 390 light-years from the supermassive black hole at the center of our Milky Way. In the year 2009, astronomers utilizing the IRAM 30-meter radio telescope in the Sierra Nevada mountains of Spain pointed their massive parabolic dish at this specific cloud. They were analyzing the millimeter-wave photons drifting out of the dust. Molecules in space tumble and rotate, and as they slow down, they release photons at highly specific, mathematically predictable frequencies. By reading these frequencies, the scientists detected the undeniable spectral signature of a complex organic molecule known as ethyl formate, chemically written as C3H6O2. Or notice how the universe mirrors the comforts of Earth. Ethyl formate is the exact chemical compound responsible for giving raspberries their distinct tart flavor. Furthermore, this specific ester carries a very rich, sweet scent, famously smelling remarkably like aged rum. Because photons carry the precise, unalterable fingerprint of the molecules they interact with, they bring the sensory data of the galaxy directly to our instruments. The center of our galaxy, wrapped in freezing dust, is saturated with the invisible essence of sweet fruit and warm spirits, delivered across the dark by weightless waves of energy. Picture this delicate transfer of energy happening on a much hotter, visually spectacular scale. If we trace a path toward the northern constellation of Draco, we encounter the magnificent Cat's Eye Nebula, scientifically cataloged as NGC 6543. First observed by the astronomer William Herschel in 1786, this planetary nebula offers a breathtaking lesson in thermal physics and color. The dying star at the very center of the Cat's Eye possesses a scorching surface temperature of approximately 80,000 Kelvin. This immense heat means the star is shedding massive amounts of highly energetic, invisible ultraviolet photons. As these fierce UV waves stream outward, they crash into the surrounding shell of expanding gas. The physical collision is so intense that it violently strips electrons away from the oxygen atoms floating in the cloud, creating what physicists call doubly ionized oxygen, or O3. But nature always seeks a state of rest. As those agitated oxygen atoms cool and settle back into a stable state, they must release their pent-up energy. They do this by emitting a brand new photon. Due to the strict, uncompromising laws of quantum mechanics, an O3 atom can only release a photon at a precise wavelength of 500.7 nanometers. When human eyes, or the lenses of the Hubble Space Telescope, capture light at exactly 500.7 nanometers, it registers as a vivid, luminescent teal. The serene, cool sea-green glow of the Cat's Eye Nebula is not a random splash of paint. It is the direct mathematical consequence of invisible heat being transformed by oxygen into a cooling, soothing wave of visible color. Returning closer to our own home, we can observe how these energetic collisions create the softest, most ethereal textures visible in our atmosphere. The Earth is shielded by a massive, invisible magnetic field known as the magnetosphere. When our sun releases a continuous stream of charged particles known as the solar wind, this magnetic bubble catches them, safely funneling these high-energy travelers toward the north and south poles. When these charged particles finally strike the uppermost layers of Earth's atmosphere, they collide with our local atmospheric gases, transferring their kinetic energy and initiating a cascade of glowing photons. We call this phenomenon the aurora borealis in the north and the aurora australis in the south. The visual texture of an aurora is often described as flowing silk rippling slowly across the black velvet of the night sky. This smooth, waving movement is the actual visible shape of Earth's magnetic field lines, swaying in the solar wind. The colors of this atmospheric ribbon are dictated entirely by altitude and chemistry. When the incoming solar energy strikes oxygen molecules high in the thermosphere, at altitudes between 100 and 300 kilometers above the surface, the oxygen responds by releasing a shower of photons at a wavelength of exactly 557.7 nanometers. This specific emission paints the sky in a brilliant, calming shade of pale green. If the solar particles penetrate slightly deeper into the atmosphere, they encounter a higher concentration of nitrogen gas. Nitrogen requires a different amount of energy to become excited, and when it settles, it releases photons with much shorter wavelengths, typically around 428 nanometers. This process blankets the lower fringes of the auroral ribbons in deep, soothing tones of blue, violet, and rich purple. The auroras are essentially an enormous planetary-scale neon light, one where the electricity is provided by the sun, and the glass tube is the Earth's atmosphere itself. It is profoundly humbling to realize that the sensory world, everything you see, everything we can mathematically smell or hear in the data of the cosmos, is governed by the gentle, tireless labor of the photon. Every rich scent of a molecular cloud, every rhythmic pulse of a dead star, and every flowing ribbon of polar light is a story written in the language of electromagnetism. You are witnessing a universe that is endlessly recycling its energy, cooling the fierce heat of stellar cores into the quiet, beautiful geometry of colored light. As you observe this grand, silent machinery, there is nothing to solve, nothing to calculate. There is only the steady, comforting flow of energy, painting the dark with the physics of creation. We now begin our final descent, tracking the very last moments of your boundless journey as a particle of light. The time has come to bring this magnificent high-speed flight to a gentle, comforting halt. To truly understand how a photon's life concludes, we must carefully observe the step-by-step process of absorption unfolding right now within the quiet sanctuary of your own room. Imagine a single photon emitted from a bedside lamp just before the switch is flicked off, moving at approximately 299,700 kilometers per second through the localized mixture of oxygen and nitrogen in your bedroom air. This light particle takes only a tiny fraction of a nanosecond to cross the physical space between the bulb and your resting form. As it travels outward, it is governed by a strict mathematical rule known as the inverse square law. This principle dictates that as light radiates from a source, its intensity drops exponentially. If the distance from the lamp is doubled, the light's energy is dispersed over 4 times the area, rendering it exactly a quarter as bright. This gradual mathematical softening is the universe's way of naturally dimming the environment, systematically preparing a quiet space for rest. As the light source goes dark, your biology begins a beautifully choreographed, step-by-step sequence of adaptation. First, the muscles in your iris respond to the fading photons. Your pupils slowly dilate, expanding from a constricted daytime diameter of about 2 millimeters up to a wide 8 millimeters. This structural widening is an attempt to capture any remaining stray photons bouncing around the dark room. Next, a chemical process initiates within your retina. The pigment molecules that were bleached by daytime glare begin to painstakingly rebuild themselves. This delicate chemical regeneration takes approximately 30 minutes to fully complete, slowly shifting your eyes into their maximum state of dark adaptation. When a final, rogue photon strikes the soft, heavy fabric of your blanket, its existence as a traveling electromagnetic wave instantly ceases through a mechanism quantum physicists call wave function collapse. The photon transfers its remaining energy directly into the atomic structure of the cotton or wool. In that fraction of a second, the energy is converted into a phonon, a microscopic quantum vibration of heat. The light is officially gone, completely absorbed, leaving behind a tiny lingering warmth, a microscopic thermal blanket woven from exhausted starlight. With the room enveloped in shadows, your physical form begins to power down. Observe the way your eyelids gently close, forming the ultimate barrier. The human eyelid is a biological marvel, featuring the thinnest skin on the entire human body, measuring exactly 1 millimeter in thickness. Despite this incredibly delicate profile, the closed eyelid effectively blocks over 99% of all incoming visible light. The only photons capable of penetrating this biological shield are those with long, gentle wavelengths, measuring around 700 nanometers. These low-energy red waves pass easily through the microscopic capillaries of your skin, which is precisely why bright environments appear as a dim, soothing crimson when your eyes are shut. With the visual input securely halted, a profound chemical cascade triggers deep inside the center of your brain. The total absence of light signals a small pea-sized organ situated in the epithalamus, known as the pineal gland. This tiny structure initiates a highly precise, two-step enzymatic process. First, it gathers stored serotonin molecules and converts them into a chemical intermediate. Then, an enzyme called ASMT transforms that intermediate directly into melatonin, the primary hormone responsible for regulating your circadian rhythm. As this soothing molecule gradually floods into your bloodstream, it systematically binds to receptors on every cell in your body, signaling that the solar day has officially concluded. Simultaneously, a dual-lobed brain structure known as the thalamus begins its essential nightly routine. The thalamus acts as the brain's central relay station for sensory information. During your waking hours, it actively routes sight, sound, and touch directly to the cerebral cortex for conscious processing. But as you transition towards slumber, the thalamus slowly begins to close these neural gates. It steadily blocks external sensory signals from reaching your active mind, intentionally constructing an insulated silent void within your own consciousness. As these gates close step by step, the electrical rhythm of your brain initiates a gradual downward shift in frequency. While awake and alert, your brain fires rapid, chaotic beta waves, measuring between 13 and 30 hertz. As you relax against the pillow with your eyes closed, this electrical pulsing smooths out into rhythmic alpha waves, cycling steadily at 8 to 12 hertz. Gradually, as you sink completely into slumber, your brain will ultimately transition into deep, rolling delta waves. These massive, slow oscillations measure between 0.5 and 4 hertz, representing the most restorative, profound state of cellular repair your body can experience. Accompanying this electrical deceleration is a necessary physical thermal shift. To achieve the absolute deepest stages of rest, the human body must actively lower its core temperature. Your hypothalamus orchestrates a mechanical process called vasodilation, gently expanding the blood vessels in your hands and feet. This deliberate expansion allows your internal heat to radiate outward, safely dropping your core body temperature by approximately 1 to 2 degrees Fahrenheit, or about half a degree Celsius. This internal cooling beautifully mirrors the freezing peace of the deep cosmos, instructing your metabolism to completely surrender to rest. As your biology settles into this quiet, slowing rhythm, it is the perfect moment to reflect upon your deeply physical connection to the cosmic forces we have explored tonight. You are not merely a separate, distant observer of the universe. You are a direct biological product of its ancient step-by-step mechanics. The solid carbon atoms that form the foundational backbone of your DNA were not created here on Earth. They were forged billions of years ago inside the crushing, pressurized cores of ancient red giant stars. Through a magnificent sequence known as the triple alpha process, stellar cores burning at temperatures exceeding 100 million Kelvin violently forced 3 separate helium nuclei to fuse together, step by step, creating a single highly stable atom of carbon-12. When those massive stars eventually ran out of fuel and died, they scattered this vital elemental ash across the dark galaxy, patiently providing the structural building blocks for your physical form. The oxygen gas you are quietly breathing in right now, chemically bonded as O2, was synthesized during the intense carbon-burning phase of those same dying stars. Furthermore, the calcium that gives crucial strength to the skeleton currently supporting your weight on the mattress required an even more dramatic sequence of events. The isotope calcium-40 is synthesized in the absolute final fractions of a second during a massive supernova explosion, a catastrophic event where temperatures briefly spike to an unimaginable 3 billion degrees Celsius. Even the iron currently coursing through your veins, securely bound inside the complex hemoglobin molecules of your red blood cells, is a celestial artifact. Iron 56 is the absolute final, heaviest element a massive star can naturally fuse in its core before the energy required for fusion exceeds the energy produced, triggering a sudden absolute gravitational collapse. Every single time your heart beats, pushing blood through your resting limbs, it is pumping the metallic remnants of a collapsed star to successfully deliver stellar oxygen to your sleeping brain. You are, quite literally, beautifully organized stardust, breathing the chemical exhaust of ancient galaxies, waiting safely in the dark for the morning sun. We have traveled from the blinding 15 million degree core of a young star to the absolute comforting silence of a darkened bedroom. The ancient photons that began their journey 26,000 light-years ago from the dense, swirling center of the Milky Way have finally completed their impossibly long flight. They have collapsed, their radiant energy fully absorbed, their cosmic purpose fulfilled. They rest now, completely still, just as you do. Now, we gracefully transition our focus away from the distant stars, turning entirely inward. The long journey is over. There is no more physical distance to cover, no more incredible speed to calculate, and no more light to process. The steady, reliable gravity of Earth holds you safely and securely to the surface of a spinning world, perfectly protecting you beneath a thick, atmospheric blanket of nitrogen and oxygen. Notice the gentle, repetitive, mechanical rise and fall of your chest. It is as perfectly rhythmic and mathematically certain as the slow orbit of the planets around the sun. With every single exhale, your physical form becomes slightly heavier, sinking effortlessly into the soft, supportive layers beneath you. You are completely safe. You are entirely at peace. The expansive universe outside your window is quiet, watching over you. The complex, beautiful systems of your body are functioning perfectly, powered by the ancient recycled energy of the cosmos, slowing down into a state of profound, absolute stillness. Embrace the heavy, comforting dark. Release any remaining lingering tension in your muscles, allowing the slow, steady pull of gravity to cradle you securely in place. The light has finally completed its multi-billion-year journey, and now it is time for your mind to find its own silent, peaceful horizon. Rest now in the quiet, empty void. There is absolutely nothing left to do, nowhere left to travel, and nowhere left to be. Just the gentle, rolling electrical waves of sleep carrying you softly into the deeply restorative night. Good night.